Welcome back, children. This is System of Equations Unit Review for Tuesday night. There'll be an upcoming quiz. Maybe it'll be on Wednesday, maybe it'll be Thursday or Friday, but it'll wrap up Systems of Equations, and then we'll be moving on to our next unit. Let's dive in. The significant difference between last week in the quiz and this final material is we're just stepping it up a notch. You're going to choose what type of method you would like to use, and the equations are not going to be as simple as they were on the quiz last Friday. They were kind of given to you in the easiest form. So let's look at things here, break it down a little bit. Now that you know all three methods, you guys can choose how you want to solve. Okay, so if you're looking at a problem, graphing would be an option if both equations are solved for y, or if you just want to solve them both for y. If you like graphing and you look at a problem and think you can get it solved for y on both equations, then that makes slope-intercept form, and you're good to go, right? Y equals mx plus b. That's just solve for y. So if you want to solve both equations for y and you like graphing, you can use that method. Substitution. Okay, that's an equation solved for x or y. So if you have it solved for a variable, either x or y, or if it's close to it, if all you have to do is like cancel one term and move it over, that's really easy. That's set up for an easy substitution. You might use that method. Elimination is when both equations have coefficients on both the x and y. In other words, it's really not a graphing or substitution ready type of problem. So elimination is kind of the go-to if nothing else seems easy. And plus elimination is kind of easy to use in any case. You just have to be able to move some terms around so that the two equations are lined up. The x's and the y's and the constants are in the same position, and then elimination is easy in any case. So let's kind of walk out this idea of choosing the most efficient method. A, B, C, D, there's 4 systems. Think about what method you would like to use to solve each of these, and in addition, write out, like, let's say the first 2 steps to solving, okay? Like you might say on that one, I'm going to use substitution because it's already solved for y, so I'm going to take what y equals and plug it into the other equation, okay? So now you're already on your way. You've kind of walked out the idea of how you would substitute. So those 4, pick which method you would use and what the first, say, 2 steps would be to get you along that route. Pause the video, and I'll come in behind you in just a minute and walk through those myself. Go. All right, let's take a look. Let's look at A. Obvious go-to here with A. I've got an equation solved for y. It's already in slope-intercept then, so I can graph that line. And the second equation would be really easy to solve for y just by dividing off that 3. So I might graph that first one. That would be a really easy go-to, and that's how you would graph it. So if you said graphing, that's what you should have told me. A second thing you could have done on this equation was, since it's solved for y, you could have gone with substitution. We see right here exactly what y equals, so you could have plugged that in for the y in the other equation and had 3 times the negative 3x plus 4, and then you would just have an equation with x to solve and finish. I'd say either of those would work. All right, B. If we look at B, nothing is solved for a variable or easily solvable for a variable. If I try to divide off that negative 8 or that 11, I'm going to get multiple fractional answers. Same thing up here with the 4 and the 5. If I try to divide that coefficient off and solve for x or y, I'm going to end up with ugly fractions. So B to me is a really obvious elimination problem. I would think about rewriting things so they're all on the same side. So I would move my negative 5x over to make positive 5x. And now we've got everything on the same sides, and I can just switch the order up with the 11x on the other side of the 14 here, just so things look the same. And with that, everything is lined up. So now I would just use elimination and multiply. So I can make an easy opposite pair with the y's by just multiplying the whole top by 2. And I'll have an 8y on the top and a negative 8y on the bottom. That would probably be the route I would go. It's an easy elimination problem. Now, if you pick something else other than what I'm picking on these, that is perfectly okay. You're able to use all three methods. All three will give you the correct answer on all of these, but just realize you're going to get fractional ugly type answers on some of these if you don't pick an easy method. And A, really, you could also use elimination. Elimination always works, I think, fairly easily. All right, C. I'm looking at C. That's really, really easy to solve for X. I would probably immediately just go substitution by moving that over. And now I've got an equation solved for X, and I can immediately plug in for the X right there, and just have 3 times that quantity, and then just solve that bottom equation for Y. So I would probably go substitution. Yeah, I think that would be easy. And again, you can always go with elimination. Now that I just moved that Y over, just like I did, you also could have used elimination there. That would be fairly easy. These X's could make an opposite pair by just multiplying the whole top equation by -3, and then you would get -3x and 3x as an elimination opposite pair, so that would also be pretty easy to do. All right, last one, D. It'd be easy to solve that equation for Y, so substitution is an obvious option there. And that's about it. I'd say substitution there, or as always, just do elimination. And we could just switch the order of the 2 terms on the top. Just put the 3x in the front. And now you've got x's and then y's. And elimination would be it's always fairly easy, but for elimination, I could now just multiply both equations. If I wanted to get rid of the x's, I could multiply by 5 on top and 3 on the bottom, make one of them negative, and that'll give me a -15x, that'll give me a positive 15x, and so I'd get a cancellation opposite pair on those x's. So I could also use elimination there. All right? Now the point of those was to hopefully get you more comfortable with, as you understand all 3 methods, choosing the easy route, or frankly, the one that makes sense to you. I mean, realistically, some of you might not really get elimination, but you do get substitution. So substitute. Look for the easiest way to do that. Whatever's going to work to get you through, I'm okay to go with. All right. Now, let's kind of flip things around a little bit. Can you solve using all 3 methods? This is kind of stretching you out a little bit. This is where it's a little harder than last week, because neither of these equations are in an easy, obvious form. All right, to use all 3 methods, okay? So go ahead and pause it and see if you can solve that system all 3 ways. And of course, you should get the same solution all 3 ways. Go. All right, let's take a look. Substitution. I'm going to take those 2 equations. And if I'm going to use substitution, I'm going to look for the easy solving for a variable. And it looks like, in my opinion, this right here, getting rid of that -2 on the y will leave whole numbers, because -2 can divide into both the other values. If I looked at the other equation, 2 and 3 and 6 on the top equation, nothing's going to divide evenly into the other values and get away from fractions. But I can get away from all my fractions if I use substitution by solving for that y. So that's what I'm going to do. All right, move that -4 over, make it a +4x. Divide off that -2. And I end up with y equals -2 minus 2x. And now I'll just substitute that into that other equation. 2x equals -3 times, and plug in -2 minus 2x plus 6. Okay, I've substituted. Now I just got to solve. my 6 plus 6x plus 6. Wow, just like the double equation. All right, we got a 12 there. And I'm going to move my 6x over to the other side. Negative 4x equals 12. Divide off that negative 4. We've got the x equals negative 3. Okay, we're halfway home. I'm going to go up and plug into right here, take out that x, make it a negative 3. And we end up with 6, negative 2, plus 6, which is 4. So y equals 4, and there we go. Negative 3, 4. There's the first method. Getting a little tight there. All right, elimination. It's going to be a bit quicker and easier. First thing, let's put everything in the same place. Let's move the y over here. So we'll have 2x plus 3y. Move them to the left side, and then now things are on the same side, the same location for both. And I don't need to multiply both equations, I'll just multiply the top one by 2. That's all I need to do. And I'll rewrite it right here below. So 2 times 2x is 4x, 2 times the 3y, 6y, 2 times 6, 12. Add those together, there's that opposite pair. I wanted to get my x's to cancel to create that opposite pair. And I'm left with 4y equals 16, divide that off. And I see that the y equals 4, which is what I got last time, so I'm on track. So now I'll plug in, I'll just pick the top equation. And I get negative 12 plus 6, which is negative 6, equals 2x, and divide off that 2, and see that my x equals negative 3. And I end up with that negative 3, 4 again. All right, 2 for 2, we're feeling good. Graphing. So that first equation, let's rewrite it. We'll move that negative 3y over and make it a positive 3y on the left. I'll move that 2x to the other side and make it negative 2x on the right. And let's get rid of that 3 to get it solved for y. So now we have y equals negative 2/3 x plus 2. And let's go ahead and graph that guy. Up 2, and then down 2 over 3. And I'll go the other way just in case. Up 2 over 3. All right, there's my first line. Let's pick a new color. Negative 4x minus 2y. Okay. All right, let's move that 4x over. So now we have a negative 2y. Don't forget your negative. Plus 4x now, plus the 4. Divide off that negative 2, and we get y equals negative 2x minus 2. So down 2, and the slope is down 2 over 1, which isn't going to help us, so I'm going to go up 2, left 1, and do it again, and do it again. And there we go. I see my solution. It's right there, and it's at the x value of negative 3 and the y value of 4. And there we go. 3 for 3, guys. It worked out. Negative 3, 4, negative 3, 4, negative 3, 4. On a system that was not set up as an obvious choice for any of them. You had to do work on all of them. So if you could do that, if you just solve that one correctly in all 3 methods, give yourself a big pat on the back. You're getting some solid algebra skills. Good work. Dang it. Hit the wrong button. Random fact. Car manufacturer Volkswagen makes sausage as well, and they make more money off the sausage than the cars. Crazy. Moving on. Here's your homework, guys. 3 systems problems. Choose whichever method you want, and don't forget about no solution and infinite solutions. They're out there. All right, pause it, do those 3, and I'll come behind you, and I'll actually just give you the solutions right to start, and you can see if you're right, and then I'll work them out if you need to stick around and see what you might have done wrong. Go. All right, if you're back, let's take a look. 1, 2, 3. Oh, I love it when this stupid thing doesn't work. There we go. Okay. So there's number 1, 2, 3. On the bottom, there's your solutions. How'd you do? If you didn't get something right, let's look around and see what happens. Let's dive in. Okay, first one. I'm just going to use substitution. I'm going to move that guy over and go plus 3x. Then I'm going to flip all the signs to make it a positive y, and now I've got negative 4 minus 3x, and I solve for y, it's going to go right there, 2 times, I'm just filling in that bottom equation, and I'll give you a different color so you guys can track with me, negative 4 minus 3x, alright, distribute, we got negative 8, minus 6x minus 5x, equals 58. Combine those like terms, negative 11x. And add over that 8. What's that? 64? No. Had to pause for a second because I made a mistake. Thankfully, it was just right here. 58 and 8 is 66. There we go. Right off that negative 11, we see that x equals negative 6. We'll go plug him in right here at the top. Y equals negative 4 minus 3 times the negative 6, and we see 18. Negative 4 plus 18 is 14. And was that correct? Yes, it was. Good. All right, number 2. I'm going to go for elimination. So I'm going to move this guy over and move this guy over so they're both in the same form. So that'll be a negative 2x plus y equals positive 7. Okay, now I'm just going to take this equation, move him right down. I'm going to put the x in the front. It's already on the left side, but I'm just moving it in front of the y term. And the minus 4y I'm moving behind. Notice they're on the same side of the equation. They both stay on the left, so no signs changed. I just flipped the terms order so they line up with the top. And now I'm going to do some multiplying, and I'll just multiply that equation by 4 because that'll make negative 8x with the positive on the bottom, and that'll make things easy. So now I've got negative 8x plus 4y equals 28 when I multiply that guy right down to here, and then I'll add, cancel that opposite pair. Oh, look, another opposite pair. Means nothing's left but 0, and nothing's left but 8 on this side. I don't have to go any farther. That's untrue, which means it's a no solution problem, and I'm done. Last one. That kind of looks like an easy elimination or substitution. I'm going to go with elimination. I like that one best. Just want to move my y over there, make it a negative 4y. And both equations are already matched. And I'm going to multiply to make the x's cancel. So I'll multiply by 2 on top and then 5 on bottom to make 10s for both x's. They're already opposite signs, so I'm good to go. So that's going to be a negative 6y plus 10x equals, and whatever 2 times 94 is 188, negative 188. Okay, that's this guy. Now I'll do this guy. Negative 20y minus 10x equals negative 150. The values are getting a little bigger, guys. Hope you're okay with that. I'm trying to step it up and give you a little more rigor with this. And what's that going to be? Negative 338. And if you're not, you guys probably shouldn't be doing a lot of these in your head. I'm the teacher. You guys should be working this stuff out. Right there, classic mistake where kids are going to mess up. They're going to focus on that long division and move on their way and forget all about negatives. Don't do that. Okay, 26 into 338. 26 will go in 3 and 33 once. There's a 7 left over. Bring down your 8. It's going to go into that 3 times, exactly even. So the answer is 13. And go plug it in somewhere to finish this bad boy. I'll pick that second equation because I can see it. And at this point, I think you know what to do. We'll plug in the 13 right there, and I'm just going to stop because we know what x is going to equal once we plug in. It's going to equal negative 11. We already had our 13. All right, there you go, guys. Good luck on the upcoming quiz. Ask me if you have questions. Come to tutorial.